All right. Oh, yes. And the fences have gone back up at the White House. I think those went away during Biden's term, but they've been brought back today or yesterday. So I think this is the conspiracy theorist to me, of course, but I think something's about to go down for which they know people are going to be pissed about. Not that that hasn't already been a day by day occurrence, but still,
It's supposed to
this
be
one is going to be pretty
Saturday.
egregious.
Well,
Oh, hands off is doing another. Wait a minute. That
well,
already happened. No. Yeah, that was
past
last
few,
week.
past few days, all my retirement accounts have been undergoing a steam bath. So,
Yeah. And all the billionaires have said, don't, uh, don't sell anything yet because eventually it'll go back up. And I'm like, uh-huh, sure it will.
hey, well,
Mm. All right. Okay. So last time we got through, wow, this is what I get for not
Yeah, I think I marked it.
remembering.
Falling.
Thrust.
Oh, thrust. Yeah.
Yeah.
But,
We got through thrust and now we're going to go through falling.
mhm.
And for those watching on the cast, if there's anyone watching, we're just going to be reading out um, the main sections and then discussing what's in um, the remarks and Zuzats loosely. This section is actually pretty easy to understand if you read it closely. I didn't even read the commentary on it yet. So, Kyle, can you start us out with 267?
Falling is relatively free motion. It is free, but because it is posited by the notion of body and is thus the manifestation of the body's own gravity. It is therefore immanent in the body, but at the same time as only the first negation of externality. It is conditioned, consequent, uh, consequently, the separation of the body from its connection, with the center is still a contingent determination externally posited.
Thanks, Kyle. So, um, if you want to understand where Hegel is going with trying to talk about matter and what it does, this is a pretty central paragraph. You'll see why in a bit, but basically, what he does is he says that the matter itself determines what it does. Usually, in modern, I, I would say modern bourgeois physics, but really, I mean, it's just, you know, physics in general from Hegel's time even up to now, the conditions under which matter moves has always been posited as something that comes from outside it. And those forces that act on the matter have been separated into several parts or forces that act from the beginning. And this is extremely vague on matter to make it go the way it does. Hegel, in contrast, takes a different approach by determining all matter's potential abilities within itself and its being what it is, I guess you could say. So um I didn't do a lot of uh I did I didn't start off with a lot of highlighting here, but I'll just read a little bit of it. The laws of motion concern magnitude and essentially that of the time elapsed and the space traversed therein. They are mortal discoveries which redound to the greatest honor of the analysis of the understanding. The next step concerns their proof independently of empirical methods, and this proof has been furnished by mechanical or mathematical mechanics, so that even a science based on empirically ascertained facts is not satisfied with the merely empirical pointing out or demonstration. Pointing out is by the way, is the fundamental action of perception. which Hegel talks about in the phenomenology of spirit, if you recall. So, what he's differentiating here is that matter and motion can be measured and analyzed as to what happens and sort of put together into a quantitative, what's the word? Uh, Not proof, but equation. You can you can account for all of these things that happen mathematically with numbers and or characters that stand in for the numbers, so that you can plug in any number you like, and then you will you will see. Well, you can imagine the world coming into motion in your mind. Proof independent of empirical methods is what Hegel intends with his system of the philosophy of nature. Um, let's see here. So he says more precisely, the determination of magnitude, which here contains a relation of powers, is reduced to the form of a sum of two independent elements, and in this way, the qualitative determination dependent on the notion is destroyed. So this is getting more detailed about the same thing I just talked about. From the law thus supposedly proved, it is concluded that in the uniformly accelerated motion, velocities are proportional to times. In point of fact, however, this proposition is nothing but the quite simple definition of uniformly accelerated motion itself. The simple uniform motion is one in which the spaces traversed are proportional to the times elapsed. And he goes into the math. And I'm not one for understanding or keeping physics in my head very well, but basically he breaks down the basic formulas. Velocity.
Yes, I mean distance. I'm used to X, but yeah, it's velocity,
Yeah,
acceleration.
it's like velocity over time or something like that.
Yeah, so that's distance over time squared.
Yeah, and he also has another one, S over T. It's what is that?
That's just S is distance. So
Okay,
that's velocity.
space over time
Yeah.
is what it is.
Okay, yeah.
High school
Yeah.
physics teacher in Hegel.
Yeah.
Yeah, which I'm sure he was well familiar with by that
He
time,
taught
being
this
a
in high school.
high
Yeah.
school principal himself.
Yeah, he taught physics.
You know how many high school principals I've met who probably couldn't touch a tenth of this stuff today? It's ridiculous. They're all administrators, not teachers. Sorry, I promise no politics. You know, we're not Marxists here. We're just bourgeois physicists. I'm just kidding. Okay, so he goes through the math. And he says, as against the abstract uniform velocity of lifeless, externally determined mechanism, the law of descent of a falling body is a free law of nature. That is, it involves an element which is determined by the notion of body. So basically, the body itself and its specific gravity, its specific weight, is more determinant on what happens to the matter or what happens between the matter and other matter, or matter in space itself, so on and so forth. Since it follows that the law must be deducible from this notion, what has to be done is to show that the way in which Galileo's law, that the traversed spaces are proportional to the squares of the elapsed times, coheres with the determination of the notion. Here you see in a very simple statement the general statement of the rest of the philosophy of nature. This is what he wants. This is what he is aiming to do, is build a philosophy of nature in which the empirical, I guess you could say, proofs of what nature does externally match up with the internally necessitated structure of nature as an immanent system. Okay. And that system is organized in thought. Okay. We're not talking necessarily, we are talking about reality, but we're also talking about our ability to order it such that it is logically necessitated. And this conforms with the rest of the system of logic and of spirit. which this is the second part of. So, yeah. Um, hang on. Hang on just a second.
Right.
Sorry, guys. So, so the rest of the section, he basically just further details what's going on with this, and in logical terms. I'm not going to read all of it because, well, maybe I should. Um, yeah. So he's detailing out why this is so. He says space is a sunderness, meaning it falls apart. It falls into parts, and its magnitude is no other than that of time. For the velocity of this free motion means precisely that space and time are not external or contingent in relation to each other, but that they form a single determination. They relate to each other constantly. Space-time is is not just an abstract concept, honestly. It's how reality works. And that's what he means by they're not being contingent or external to each other, but immanent as a single determination. But the form of the mutual externality of space, the form opposed to unity as the form of time, and without the indeterminate intermixture of any other determinateness, whatever is the square. This part I didn't understand exactly. He says magnitude is coming outside itself, but solely in accordance with its own determinateness. I don't know.
Brings itself to a second. Oh, basically, it's space relating to itself. So, we had how space itself kind of became planar. It's the same basic thing here, where space is relating to having to relate to its spell itself has to require two dimensions.
Yeah. Okay. Yeah, that makes sense. This is the proof of the law of descent of a falling body as derived from the notion of the thing. The relation of powers is essentially a qualitative relation and the only relation belonging to the notion. There remains this to be added with reference to what follows, that because the motion of falling is still conditioned in its freedom, time remains only an abstract unit as an immediate number. Similarly, the quantitative determination of space only attains to the second dimension. So I made some notes and I'm going to read them through real quick as we go through the Zusats. So he says, in the motion of falling, it is only the quest for the center, which is the absolute factor. And yeah, in other words, bodies fall simply on account of their heaviness. And in this respect, a large body and a smaller one smaller in weight, are equally heavy. So he's already talking about the lead bullet and the feather and how in a vacuum. And this is awesome because like this is in an era before you could actually test this out reliably, right? Like in actual outer space. In a vacuum, bodies fall with equal velocity. Okay, so you can tell he's already on the cutting edge of the science of his day and in his reading of science. So anyone who tells you that Hegel was out of touch with scientific, even empirical scientific theories is vastly wrong. Wrong, at least in my opinion here. Um, let's see here. He goes through. It is in uniformly accelerated motion that we first have the living motion of nature conforming to law. Yeah. So regularity is what he's looking for. In mechanics, this is proved mathematically by representing the so-called force of inertia by a square and the so-called force of acceleration by a triangle fitted onto it. This method is of interest and is perhaps necessary for the mathematical exposition, but it is necessary only because of that exposition, a tortuous one. These mathematical proofs always presuppose what they set out to prove. They then, of course, describe what has already been admitted. This mathematical procedure comes from the need to convert the relation of powers into one more amenable to mathematical treatment. In this way, the motion of a falling body is analyzed into two parts, but this division has no reality and is merely an empty fiction introduced only to aid the mathematical exposition. So if you think about dissecting a body, we take out all the parts, we look at them, and so there are several parts, whereas there's one body that works, right? It's just like that. Reality works as a single system, but the exposition externally of those parts of that system necessarily fall outside of it, are divided up. Hang on just a second. I'll be right back. All right. Sorry about that. Okay. Jim, if you could read 268 for us.
Following is the merely abstract positing of a center in whose unity the distinction of particular masses and bodies is posited as sublatent. Consequently, mass, weight, exercises no influence on the magnitude of its motion, but the simple being for itself of the center is, as this negative self-relation, essentially a repulsion of itself, a formal repulsion into a many immobile, whatever, centers, a living repulsion as a determination of them in accordance with the moments of the notion and an essential interrelationship of those centers, thus differentiated according to the notion. This relation is the contradiction of their independent being for itself and their notional interconnectedness. The manifestation of this contradiction between their reality and their ideality is motion, the absolutely free motion.
Thanks. Okay. Okay, so he says the defect of the law of descent of a falling body is at once obvious in the fact that in this motion space is posited only in the first power, that is, abstractly as a line. This is because the motion of falling is partly free and partly conditioned. So you see here in the main section, he starts to get into how the center is a abstract positing. This idea of gravity, of falling toward a center, and every body in motion has a center that it's going to, is an abstractly posited being that's outside of the body. So you think of a planet and it is set in motion and it's going toward the center, but it's abstract. And its repulsion and attraction are two abstract, I guess you could say, forces on it. But he's only really talking about the repulsion here. Um, yeah, I read through this section, and
It's been a while since I.
falling is only the first manifestation of gravity, because its condition, namely distance from the center, is still contingent, is not posited by gravity. This contingency has still to be eliminated. The notion must become completely immanent in matter. Go ahead, Kyle. Sorry.
Yeah, it's because you have to lift something up for it to fall by gravity, right? But I just find it interesting now thinking about like here falling is one dimensional with a line, but we move over to absolute universal gravitation, it's two dimensional.
Yeah.
Yeah.
I don't know why I didn't notice that before.
Isn't that something else?
Yeah.
Um, and you go further down, and he says the logical one is infinite self-reference, which is self-identity, but as a self-relating negativity and thus self-repulsion, this is the other moment contained in the notion. In order to be a reality, matter must posit itself in the determinations of its moments. Falling is the one-sided positing of matter as attraction. The next step is that it must now also appear as repulsion. And it says formal repulsion must also receive its due, for it is characteristic of nature to do just this, to let an abstract separate moment exist independently. And here's what's difficult to talk about with Hegel, okay? Because on first blush, some of this seems like he is falling outside of physics as we know it and into sort of mysticism. But I think if you read carefully, you're going to find that's not the case. So he says the stars are such an existence of formal repulsion insofar as they are still undifferentiated, simply a plurality of bodies. Here we are not yet concerned with them as luminous, for this is a physical determination. We may suppose the stars and their interrelationships to exhibit a formal rationality, but they belong to the sphere of dead repulsion. Their groupings may express essential relations. These, however, do not belong to living matter, where the center is self-differentiated. So he's basically saying, yeah, the host of stars is a formal world because it is in the one-sided determination of repulsion holds sway alone. We must certainly not, and this is, yeah, we must certainly not set this system on the same level as the solar system, in which we first discern the system of reason as a reality in the heavens. The stars can be admired on the account of their repose, but they are not to be reckoned as equal in dignity to the concrete individual bodies. So matter in filling space erupts into an infinite plurality of masses. But this, which may delight the eye, the stars, is only the first manifestation of matter. So he relegates the stars to the background and the solar system as the determinate bodies. Now, on first blush, you're thinking, okay, I'm not familiar with physics as it was during the 18th and 19th century, and whether or not they were able to figure out that stars are moving around centers of their own. But I think we can go with Hegel on this one, that in looking at the stars as opposed to the solar system, in his day, they were not able to figure out that their system as systematized in reason as the planets were.
Yeah, I mean, the existence of galaxies was really a 20th century discovery. So,
Yeah.
Yeah, that was
Now,
widely argued against in the early 20th century too. So,
yeah.
Yeah.
Now, readers should not take this literally, okay? He's not saying that the stars cannot be included. He is saying that at present we haven't been able to yet, but while we cannot yet include them in the system, they basically have to be treated as the background because science has not reached them yet. Okay, whether one can see the stars or whether they're far away and we can't see them, right? They can't be taken into the system of knowledge. You understand? And when that's the case, they're almost pure contingency in terms of the system. And if they're pure contingency, until that contingency is able to be systematized and necessitated logically, it falls outside of philosophy. So when he says here, the tranquility of the stars interests the heart more keenly. It's very poetic. In contemplating the repose and simplicity, the passions are calmed. Philosophy, however, does not find the interest in this sphere that feeling does. The multitude of stars. I'm sorry. Love you. I'll get you more. I will. The multitude of stars in immeasurable space means nothing to reason. This is externality, the void, the negative infinitude to which reason knows itself to be superior. He goes on. Um, yeah. Now, and he says, now there is not much to be said about the necessity of these groupings. Herschel has observed forms in the nebula and the nebulae which hint at regularity. And then you go down, he says, this is something quite indeterminate and general. The dignity of science must not be held to consist in the comprehension and explanation of all the multiplicity of forms in nature. We must be content with what we can, in fact, comprehend at present. There's plenty that cannot be comprehended yet. And this statement, above all, explains what has just been said about the stars. We live in an era in which the stars have been shown to be a systematic whole. They go, they rotate around the galaxy's center, right? Or if you have a star that's sort of like been deflected, it's going in another direction, based on its interaction with other gravitational forces. And, that's been the hallmark of the 20th century, is that we now can see farther, and we can systematize those motions in
Yeah.
and for themselves.
And another thing, in Hegel's day, and even long earlier before Hegel, people speculated about the existence of other solar systems. But
Yeah.
empirically, that was the existence of other solar systems was not really demonstrated until the 1990s.
Yep. And that's something. That was quite recent.
Yeah.
That was my childhood.
Yep.
Yeah, God, that reason. Also think about the pictures of the planets. They were only like, a decade old when I was going to elementary school.
Yeah.
And Hegel here, I mean, he says it straight out at the end of the paragraph. He says, at present, in Hegel's day, the only rational interest offered by the stars lies in their geometrical forms. In other words, astrology. The stars are the realm of this abstract, infinite diremption, and on their constellations, contingency has an essential influence. And he's right, right? In his day, the stars were pure contingency. They couldn't be grokked in a systematic way yet. So that takes care of falling, which brings together matter's basic finite mechanics. And next, we're getting into absolute mechanics with universal gravitation. Kyle, can you read 269, please?
Gravitation is the true and determinate notion of material corporeality, which is realized into the idea. Universal corporeality essentially assunders itself into particular bodies and achieves conclusion with itself in the moment of individuality or subjectivity as manifested existence in motion, which thus is immediately a system of several bodies.
Thanks. So yeah, he connects up the universal with particular and ends with individuality. And those individualities are governed by the universal laws of gravitation, um, so on and so forth. So it's just the general statement of the syllogism of gravitation here. At this point, we're at C, so it's a summing up, I guess you could say, that The people who mistake Hegel's system would call it the synthesis, although we know that's not really the case. It's more the unity in its differentiation, if that makes sense. So, um, let's see what does he say here? Universal gravitation, its verification has been based on experience, which is true. As understood by the reflective understanding, it has only the significance of abstraction generally, and more concretely, only that of gravity in the quantitative determination of falling, not the significance stated above of the idea developed in its reality. So basically, he's reviewing kind of what we already know, which is that scientific observation and measurement have been chief movers and shakers of us figuring all of this stuff out. In the notion of gravity, as has been shown above, there are included the two moments, being for self and the continuity that sublates it. It has been the fate of these two moments of the notion to be regarded as separate forces. And this is really cool, corresponding to the forces of attraction and repulsion, more precisely determined as centripetal and centrifugal forces, which are supposed, like gravity, to act on bodies and independently of each other and contingently to meet together in a third something, the body. In this way, whatever deeper meaning there were in the thought of universal gravitation is destroyed again, and the notion and reason will be unable to penetrate into the theory of absolute motion so long as the much vaunted discoveries of force prevail there. So, if you're wondering what this all means, if you know your basic high school physics, the forces that make up what gravity and other forces do to bodies, they're all listed out separately and they're all accounted for separately, or rather, they're not accounted for at all. They're more like attributed to almost as properties that are externally assigned by nature acting on the body. Okay. And like you said, accounting for them logically is a well, it's you can't really, because it's more of a circular argument. They state what happens and then they measure it out and then they say, well, A equals A, right? Doesn't really tell you much. Um, so yeah. Um, trying to think. All right, I'll just read this out real quick. In the syllogism, which contains the idea of gravity, gravity itself, namely as the notion which through the different particular bodies develops into an outer reality and at the same time shows itself in the ideality and reflection into self of these bodies, in this syllogism are contained the rational identity and inseparability of the moments, which elsewhere are conceived as independent. Motion, as such, has meaning and existence simply and solely in a system of several bodies that stand in relation to each other, but in a different specified relation. This more precise specification in the system syllogism of totality, which syllogism is itself a system of three syllogisms, has been indicated in the notion of objectivity. So it's not just the syllogism; it's three syllogisms. So again, Hegel always going with the three, and the third being the unity, I guess you could say, of the first two in their differentiation.
So
It scales all the way up.
the universal is the absolute center for here, particular the relative center of the planet, and then singular would be the independent objects.
Yeah, and they're all governed by that, I guess you could say, singular unity of universal gravitation. It governs all of them. Um, I think you can say I can't remember if it's the first syllogism or the final one, but universal gravitation is the central. Yeah, it's got to be the central term to which particular and individual are the two extremes are united, I guess you could say. Uh, that's for another read through of the logic. And my understanding of that is only schematic at this point. Sorry, guys.
All right.
So,
One area of physics that Hegel skips over basically is electromagnetism, which is, I think, probably because in his day, electromagnetic theory was still being developed.
plus electromagnetic feeling, or so in his day, you're absolutely right, Jim. In his day, the really big things could be measured. It's
Yeah,
the really small things,
yeah,
which include electromagnetism and the forces involved in very small particles, that was still very schematic, if it was at all.
yeah. I mean, if the electromagnetic theory had been more fully developed in his time, he would have had to address the issue of, can you unify gravitation with electromagnetism, which was the issue that Einstein spent his last years working on.
Which no,
It's still an unsolved issue problem.
yeah, which notionally you can. It's just that showing your empirical experiments, you couldn't exactly experiment in the field yet. Um, today, today we take for granted the very small scaling with the very large, but at the time, he skipped over that field. Um, I re In that vein, Jim, I'd
Sure,
really
he
love
was
to read an
familiar with what
article
was
where
going on
where
at the time, but I think he realized it was not sufficiently developed that he could actually incorporate it into his philosophy of nature.
I'm wondering where he would have done so had he done it. I assume right here,
Yeah,
although he would run into the problem of finite mechanics and quantum mechanics
yeah.
and how they fit together, and that's still an empirical problem that we're dealing with even up to now. Hmm. Okay, so he says, and he gets really specific about this in the Zusatz. He says the solar system is in the first place a group of independent bodies which stand in an essential relationship to each other and are heavy, but which in this relationship maintain themselves and posit their unity in an other outside them. So Kyle, you remember phenomenology of spirit, the perception where you have the thing and it has properties, but those properties indicate that there's a universality outside of the thing, which indicates that there are other things just like that thing, but it's not right in front of you, hence the universal. That I think comes into play here with the plurality of bodies. It's not just an indeterminate, but the difference is posited, he says. The determinants of this difference is solely that of absolutely universal centrality and particular centrality. These two determinations, bless you, yield the forms of motion in which the notion of matter is fulfilled. The motion falls into the relative central body, which is the universal determinateness of place. At the same time, the place of the central body is also not determined, insofar as it has its center in an other, and this indeterminateness must also have an existence, whereas the place which is determined in and for itself is only one. And they say it is therefore a matter of indifference as regards the particular central bodies where their place is, and this is manifested in the fact that they seek their center, i.e., they leave their place and occupy another one. So if you're trying to picture this as you're following along, folks, think of the planet as it circles around the sun. Okay? You're thinking of the body in motion, and you don't think about a particular place, but rather the body as it seeks its center within universal gravitation, meaning it it moves around the sun thanks to gravity. He goes on. The third one I didn't really understand as much. well, hang on. No, it's basically that the planets are at different distances the uh, from the sun. Fourth, in altering their distances from one another, in other words, having different distances from the sun, and from one another, they describe a curve and return into themselves. Uh, in other words, complete an orbit. For it is only in this way that they express their independence in regards to the central body. So they're independent of the central body, and their full description for themselves in and for themselves is the full orbit. Um, Altogether, then, there exist three motions. Mechanical motion, which is communicated from outside and is uniform. This is the immediate. Okay, you come across a body and it's moving, and it appears to its motion seems to be communicated from outside and it's uniform. B, the partly conditioned and partly free motion of falling, where the separation of a body from its gravity is still posited contingently, but where so it's moving. You don't know where and you don't know why, right? Is kind of why he's saying that. And gamma is the unconditionally free motion, the principal moments of which have been indicated, which is motion that's uniform and falling. The great mechanics of the heavens. This motion is a curve, and in it, the positing of a central body by the particular bodies, in other words, the sun and its gravity, dictating the ellipse of the planet which goes around it. And conversely, the positing of these planets by the central body occurs simultaneously. So this is all happening at once, right? All that's being described is the different parts of the system. The center has no meaning apart from the periphery, and nor the periphery apart from the center. So you can't separate these out and posit them in a reality in which they existed separately. This is a complete system which describes itself in its differentiation.
The only way to even do that is consider it as a moment, not actually independent, right?
Well, right, because if you tried to abstract one and say, well, this would be happening whether a sun was there or not, then you would have to explain, well, how did it get this gravitation if the sun isn't there? And then you would have to find the contingent element that actually used to, I guess you could say, describe its gravitational, and from there, let's say you found a rogue planet, okay? And you're like, it's moving through space. And you're like, okay, I'm looking for its central center and it's not there. It's just traveling on a line. You would have to like use telescopes and whatnot to try to figure out what star it might have come from, but then was deflected off of and what deflected it, right? Those are all contingent things. And I say contingent because we haven't accounted for them in their necessity. So, so there's that. And he says both points of view, both the motion of the planet and the effect of the star are necessary, but taken separately, they are one-sided. This is a very good way to illustrate what one-sided looks like with an actual solid object. But remember, we're not actually dealing with like solid objects, or maybe we are. I think we are. But we're dealing with them in thought, and being able to reflect them well in thought, they have to be complete. So if we're just talking about the motion of the planet, but not talking about the sun, for instance, that would be very one-sided. He goes on. I'm just going to read this out and then we can talk about it a little bit. He says, gravity is the cause of falling, is certainly the notion of matter, but the notion as still abstract and is not yet differentiated within itself Falling is an imperfect manifestation of gravity and is therefore not real. So falling just separately as a category of motion is only a moment in a bigger law of gravitation, universal gravitation, I should say. The centrifugal force as the tendency to fly off at a tangent is weakly supposed to be communicated to the celestial bodies by fling to one side. Okay, a swing, a push, which is assumed they received in the beginning. Such contingency of externally communicated motion as when a stone whirled round on a string tends to fly off from it belongs only to inert matter. We must therefore not speak of forces. And this is his it's the same argument that he's been making from the beginning, is that the forces separated from each other are not some sort of spontaneous impetus that creates motion. Unfortunately, physics treats it that way because it doesn't know how to bring all of those forces together into how matter actually works. Hegel aims to. If we want to speak of force, then there is but one force, and its moments do not, as two forces, pull in different directions. The motion of the celestial bodies is not any such pulling this way and that, but is a free motion. They go on their way, as the ancients said, like blessed gods. Celestial corporeality is not a corporeality which could have the principle of rest or motion outside it. A stone is inert. The entire earth consists of stones. Therefore, the other celestial bodies are the same. This is a conclusion which sets the qualities of the whole equal to those of the parts. So here he's going into the logic, the logic of how these things work. So basically, he's repeating his argument that matter itself and its corporeality contain everything that the matter is going to do, given a certain set of conditions, rather than it being externally motivated from outside. He's trying to systematize matter. And that's it. We're at Kepler's laws right now, and those are this next section is quite long. I suggest that we attack it next time.
Yeah.
But I wanted to talk a little bit really quick before we leave about the first part of it, because he sort of sets us up nicely. So Jim, you're reading it. Kyle, if you could, Jim, can you get 270?
Yeah. As regards the bodies in which the notion of gravity is really realized explicitly, they have as the determinations of their diverse natures the moments of their notion. One body, therefore, is the universal center of abstract self-relation. Over against this extreme, there is that of immediate, self-external, centerless singularity, appearing as likewise independent corporeality. But the particular bodies are those which are characterized as well by self-externality as by being within self, are centers for themselves and are related to the first mentioned body as to their essential unity.
Thanks, Jim. So again, he's setting up the way that the syllogism of the laws of corporeality in general relate to the individual corporeal body by itself. So there he goes. The planetary bodies are, as the directly concrete ones, the most perfect in their existence. Let's see here. So he goes down and he talks about the solar system. He talks about the sun, the lunar, and the cometary body. And then he says the laws of absolutely free motion were discovered, as is well known by Kepler, a discovery of immortal fame. Kepler proved them too in the sense that he found for the empirical data their general expression. And here's where I man, this is the T right here. It has since become a commonplace to say that Newton first found the proof of these laws. Seldom has fame been more unjustly transferred from a first discoverer to another person. This reminds me of Thomas Edison and how he basically took Tesla's work and sold it, in time-honored capitalist sense. And here Hegel breaks down how Newton's formula basically repeated what Kepler had already said, but in a more detailed fashion. And I couldn't tell you one thing or another about these expressions. But he says Newton's proof of the proposition that a body in subjection to the law of gravitation moves around the central body in an ellipse gives simply a conic section, whereas the main point which was to be proved consisted precisely in this, that the path of such a body is not a circular or any other conic section, but solely the ellipse. Blah, 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 blah. So that the circumstance which determines the curve to be an ellipse falls outside the formula that is supposed to be proved, and no one has dreamt of proving the circumstance. Newton's so-called law of the force of gravity has likewise only been inductively demonstrated from experience. So he's basically showing how empirical mathematical science in its day took a look at Kepler and basically turned it into a set of formulas by which you could measure anything you like, right? A set of general mathematical laws. But the proof stops short at the observable, right? That, you point to something, you measure it, and then they say that's the end of it. It doesn't actually prove how it works. It just proves that it does. You know what I mean? Like you measure this phenomenon and you measure this one, right? And they match up, meaning they match up to the formula. Okay. So it's like in experiments. You experiment once, you experiment 10 times. It proves the law. It proves the hypothesis. But once you have a proof of that the hypothesis is happening, how do you prove why it's happening? In other words, the in and for itself of that particular set of motions, right? How do you get the full systematized picture? Well, bourgeois science is it's very difficult to get that answer. And Hegel in his philosophy of nature is, of course, pointing toward the elements that give you the tools to pull that proof. Very schematically, I would say. What do we think? Does that about cover it?
Yeah. All right.
Yeah.
So, so it's 8:55. Let me see how far we're going to have to read to cover through Kepler's laws, because there's
Got a
actually,
long Zeus that, so
what's that?
got a long keep I know people keep pronouncing it, but it's Zuzat.
Yeah.
That
Yeah, it's
goes
quite a long one.
to 83. That's
Yeah.
about 18 pages.
Did you say 80 pages?
18.
Oh,
Yeah,
18.
18.
Not the calculus defense one.
Nice. Okay. So, yeah, I think you're right. I think we should go from Kepler's laws all the way through to where it says transition to physics. Actually, no, that's not true. Let's read to 80. Let's read up until 84 because transition to physics is literally less than a page. So let's go up to the end of section 1, start of section 2 on page 84. So 65 to 84 will be for next time because it's just Kepler's laws and then the one transition piece. If you don't understand what's going on, you're not alone because I'm not a science guy. So if
Well,
you
it's
feel
basically
you're,
discussing the relationship between Kepler's laws and Newton's law of gravitation and why Hegel believed that Kepler was primary and Newton secondary.
yeah,
Whereas most physicists would make it the other way around. Newton comes first,
yeah,
and Kepler is, that's a special instance of Newton's laws.
Yeah, except he was saying Newton, what was it, didn't actually, justify a lot of his stuff. It was just sort of floating, and Kepler actually derived
yeah,
something like, yeah.
yeah. Hegel gives pride of place to not so much original derivation, but derivation of general laws to ones derived individually or particularly. And there's nothing wrong because you need both uh, in scientific discovery. But at the end of the day, you need to be able to state something that happens with consistency, absolute consistency, at least within the system that you're talking about. And Hegel drills it down, like when he talks about the stars versus the solar system, there are things that the stars will do in relation to solar systems that are part of a longer time scale and so are harder to systematize each to each other. And so if you're talking about, say, a black hole that's moving rapidly through the galaxy, let's just pretend that that's what's happening. It's coming into the solar system and affecting gravitation is would be an absolute, it would be a real event, but its time scale is such that it would be a contingent factor from Hegel's point of view, from the point of view of looking just at the solar system with the stars as just a background that are wholly unmoving and contingent. Um, it would necessitate a rewrite and or an addition to what we see here, which Hegel is perfectly fine with. Um, um, when we look at the philosophy of nature, I'm reminded strongly of certain sections of Capital where he describes the circulation of capital from money to commodity and back along the circuit of capital. And Marx is very good to remind us that all kinds of contingencies happen along the circuit that can speed it up or slow it down, right? And this would be the same thing in nature, that all kinds of things happen, contingent things that don't fit into what you could see as the systematized scientific theory. You know what I mean? But that doesn't mean that they can't be shown to be subject to the same necessity, in other words, the same laws. In fact, anything that happens will have had to have been part of the same laws, I guess you could say.
Yeah.
But it's
Paper
hard
towel.
to account for them, uh, you
Oh,
know.
I'll get paper towel.
Yeah.
What do you do? That's something?
So yeah, there you go. All right, folks. Thanks so much for sharing your Monday night with
Mhm.
me. For those watching next week, we're going to dive into Hegel's discussion of Kepler's laws and of Newton's attempts to steal them. for his own uses, or however he puts it. And then we'll get to the end. We'll get to the end of the chapter around page 84, what's called transition to physics. And then the time after that, we'll start talking about physics in general, and go from there. Everybody have a great night, comrades.
You too.
Have a good night.
Right.